My name is Liang Ming with Stanford University. I'm very glad to work with EPRI team and many other industry colleagues to kick off the conversation for this afternoon on the topic about how the AI can help on the energy system resilience. And before I move to the next slide, I want to make sure that everybody is walking to the right classroom, because we are going to have another 2 sessions running in parallel. So want to make sure that this is a session you are joining and this is a topic you are interested. This is for today's agenda. So Jeremy and I don't think Jeremy is here, but Jeremy, Rangshaw, and I are going to give a very quick introduction in terms of what is the goal for this breakout room and what have been discussed in the last several months. Then we are going to move to the next part, which is about 4 lightning talk from industry folks from National Lab, EPRI, and the different AI company going to share with us the ongoing and the relevant industry work in this space. Then starting from 4:30 Eastern time, we're going to jump into the discussion after we understand what's going on in the industry, is really try to identify some of the key gaps. Based on the previous conversation and also the relevance to today's topic, we identify 3 key topics we're going to discuss. The first one is how the AI can help to value in the resilience. And Sarah from EPRI are going to share with us some of the ongoing work from EPRI. Then we're also very glad to have Jay from CPS Energy going to share with us from the utility perspective how we can move AI projects from pilot to enterprise production. Then some of you may join this morning's session regarding the industry-wide data sharing and the governance. I'd like to take a few minutes in the end of today's conversation to kind of re-emphasize importance on this topic. Then we will discuss some of the action items and also the next step. So I also created a parking lot and for this conversation. So for the folks that if you want to chime in, during the conversation, feel free to raise your hand or just speak out, say, hey, I have a comments here. Or if you more prefer more like a written comments, and on the chart, you will see a parking lot. In this parking lot, it's a Google spreadsheet, and you can document your name, your contact information, your company, and also, would love to hear from you in terms of what is exciting work you are doing in your organization, and also what's your comments regarding the key gaps in this area. And also, we want to learn from you. Say you want to be engaged for our future events, and just drop your comments on the Google spreadsheet. In case if you have any problem access to this Google spreadsheet, just drop me a message at the chat. I will see if I can able to fix these issues. So let's move on. So what is about this grand challenge, energy system resilience? So in a recent, some of you may read a very recent Government Accountability Office analysis report regarding the energy system, especially specifically its electrical grid resilience issue to the climate change. Basically, the key message the GAO report tried to deliver is the climate change is expected to have a far-reaching impact on the electrical grid that could cost billions of dollars and could affect almost every aspect of the grid, from generation perspective, the hydro condition, and also the natural gas availability. And on the transmission side, on the distribution side, in the same thing will also have a huge impact on the end user as well. So what do we try to do on this grand challenge is to identify, development, and demonstrate and also scales adoption of advanced AI technology that could help to either predict the weather, predict the demand, and assess the equipment health condition at power plant, and also the grid condition to continuously optimize the system, the end-to-end system from generation, transmission, distribution, and the customer to minimize unplanned outage of all these assets and intelligently control the electron to minimize or eliminate the impact of the big events in the future and reduce the outage duration and also the frequency. So that's the goal for this ground challenge. And what has been discussed, EPRI has a partner with Stanford and with national labs, with NREL, with Idaho in the last almost 6-7 months, and conducted different events. We started in spring timeframe, have a AI and electrical power virtual roundtable. I believe that Jason from CPS was involved at the first roundtable. Then in the middle of April, we have a introductory training course for 2 days for the industry folks. And we gathered together from different universities, different national labs, and the industry AI companies to really talk about what is natural language processing, what is deep learning. If we have this tool, and how this tool can help us solve what kind of problem. Then 3 months ago, we have a very interesting session we call the reverse pitch. Basically, is we'd love to hear from industry folks what are the exciting and high impact use case you think about, or you think we need help and you're looking for solutions. So we gathered together about 6 different working groups in the cybersecurity area, in the smart city or smart grid area, in the climate change, and also one of the topic is about energy system resilience. And we heard from different companies. We heard from Pacific Gas Electric and talk about how they performed use AI to benefit the predictive maintenance specifically for distribution transformer. We also heard from LCRA regarding the transmission outage optimization. See how the AI can help sequence the transmission outage and also be able to analyze the impact of transmission outage on the market price. And also we heard from NIECA, Rural Co-op Association, regarding how the AI can help on the vegetation management. And also we heard from different vendors regarding how the AI can help identify the equipment health condition and for different kind of application. And more interestingly is we heard from both from utility and the AI company and regarding what's the status, where we are in terms of adopting the AI technology. So we realize that in the electricity sector, we are still on very early stage. So we have a very interesting and challenging task how we can move the AI projects from pilot to production, to enterprise level production. And another very interesting perspective we heard from almost everybody is, utility, we have a lot of data, but how we can really, overcome the data deluge challenge across utility value chain and be able to share the data with each other and really realize the value of the big data. And the last but not least is the workforce issue, and we have a very good electrical engineer in-house for most of the utilities. And then for us really want to adopt advanced technology for AI, we also need a high performance data science team. How we build this team is in-house, or we leverage different consulting companies, or how we build a long-term pipeline to have a tap into university training system, all these kind of issues. And after the May events, and EPRI and many organizations worked together and developed a white paper to document the 5 ground challenges we identified. And I'm very glad to announce that the white paper will be available tonight. and everybody online, you can go to the April site and type the very long product ID, and you'll be able to download this white paper. It's publicly available. Okay, I will stop sharing my slides. Then I think when I talk, I think a lot of folks just join us. I will repeat, we'd love to hear the feedback from you, and we'd love to hear the comments from you. There's a different way you can engage. You can either type your comments on the chat, or you can, simply just unmute yourself, just mention or ask questions, or mention some exciting things. Or alternatively, you can go to the parking lot, which is a Google spreadsheet. Put your contact information and your organization, and share with us some exciting work you are doing, and also provide comments. Okay, I will make a quick stop here and see anybody had any questions, especially regarding the logistics for today's conversation. If not, let's move on. I think the next topic, we will have 4 short presentations from 4 different organizations. And the first one, I'd like to hand this over to Dexter Lewis of Electrical Power Research Institute.
Thank you, Professor Min. Hello, everyone. My name is Dexter Lewis, and I manage research projects related to automating inspections of overhead transmission and distribution assets. I'd like to paint a picture for you before I go into my very short presentation of only a few slides, but the drone industry has advanced quite a lot, and there are some exciting solutions relating to automating the data collection process. In other words, we're getting really good at taking pictures and video without humans in the loop operating those drones. But to automate the entire inspection process, it's the data collection, but then also the data interpretation. Basically, we want to reduce the human involvement to look through those images or video to identify the broken or defective components. Many of you may be working on solutions or workflows today, but in all honesty, structure inspections are very complex. There are many components and associated conditions of those components. And then there are other variables that you have to deal with in the real world in terms of your data collection, different lighting conditions, resolutions, or perspectives. And it really makes this object detection and defect recognition task difficult. In summary, we just need a lot of data to advance these models. So I titled my slide, Together Shaping the Future of Energy. That's the trademarked tagline that is in all of our conclusion slides or final slides with our EPRI templates. But it's fundamentally our collaborative philosophy that has shown success over decades of research. And I want you to recognize that there's an opportunity to work collaboratively to build these data sets and advance the industry. So to kickstart that, I want to tell you about some data sets we have and how you can get them. The first thing is we've been wanting to build a website for you that you can just go to and get these, but unfortunately we don't have that complete. What we do have, though, is a process of you can just go to this link, get these forms that have a license form that manages our data sets. If you sign those, complete those, and send them back to ai@epri.com, we'll turn around and send you the download links for the imagery that we're contributing as a part of this effort. I want to talk about Creative Commons licensing terms for just a moment, and I think it's best if I just go straight to those locations. There are 2 different terms and licenses we're using for our data sets. For those that are already labeled, we're just managing under an attribution language, attribution license. It says you can take them and use them for commercial use as long as you just point back to give the appropriate credit of where you got them. And so in the forms that you see in that site, you actually have the attribution language there. So it's a pretty easy thing to comply with. And again, it doesn't restrict your ability to use this for academia research for commercial use. The other one we have is for non-labeled data sets, where we're trying to get industry to work together to build the value of these data sets. Having images is certainly one thing, but then having the annotations or labels that go behind those is certainly another. And we're just trying to get a community of AI interested parties and researchers to add value to these data sets. So the difference here is that it has this share alike term, and it says that if you take these data and build upon them, you must distribute those labels or those annotations under the same license. And again, the intent is to take large unlabeled data sets, open them up to the general public under these licensing, and then begin to build the metadata and the information that may go behind those. So the data sets that we have available for you, there's some defect imagery related to insulators. We've labeled these with bounding boxes identifying the insulator as well as the individual shells, and then the healthy versus defective shell conditions. Another data set that we have for you is segmented. We got 1,000 images of some computer-generated models that have transmission structures, healthy insulators, defective insulators, and then the conductors all with segmentation masks. Another one that we have is related to some utility-provided data. So some utilities do recognize the opportunity to collaborate and advance the space. So we take in their data, do an anonymization step where we remove any GPS information as well as naming, and also do a PII, personally identifiable information check, to make sure that there's nothing in the background like somebody's face or a license plate that may get us in trouble. So we've done that on these data, but they're unlabeled. And this is an experiment really to see if we put unlabeled data out there under share alike terms, who will use it and begin contributing to this data set. And then the last one that I have that's available for you today is recent distribution inspection we did via drone. Again, unlabeled data, but this imagery and these data could certainly be used for a number of applications. And we have 30,000 of those images there. A couple other things that are coming soon. We have a project from a terrestrial scan as a vehicle drives down the road, capturing images of distribution assets. We'll be adding those to this data set under, again, Creative Commons terms. And then we have data from a recent test that we did related to multi-perspective image capture on some transmission structures, and we're wanting to explore solutions related to oriented image viewers. So those would require keeping some of that metadata, that orientation and GPS information in those. So the three takeaways I want you to think about if you're a utility or just anybody working in this space is consider following our mold here and contributing to these publicly available data sets. You don't have to give them to us, but if you give them to us, we'll do that anonymization step. I also attached my taxonomies in the box link that I'll send to you, which has all of the objects that are of interest and the failure modes and conditions that we've identified that correspond to those objects. And then lastly, our whole motivation for doing this is trying to advance the space and host some of these data science competitions to further develop the models and the solutions that utilities are looking for. So I'll end on this slide again. Those are the three steps that we have, and I'm going to paste that link into the chat so anybody that wants it can begin that process, and we can get us going so that together we can shape the future of energy. Thank you.
Thank you, Dexter. I think we have time to take one quick question. Any questions? If not, let's move on. And the second speaker going to share with us a very exciting application is Prashant Srinivasan and from Symphony AI. Prashant, are you here?
Yes. Hey, good morning, man.
Good morning.
So let me share my screen here. I hope you can see the screen.
Perfect.
Okay, so yeah, good morning and good afternoon, everyone. And firstly, I would like to thank Dr. Min and Jeremy for inviting me here. It's a pleasure to be here talking in the CPRI Summit. And what I'm going to talk about is really the role of AI and FMEA on energy system resilience. And I'm part of Symphony Industrial AI. I work as a senior principal data scientist here. And I think as Dexter covered in the previous talk, it's really going to be a very collaborative effort. And it's very important that the data is democratized and, that we kind of work jointly. So it's going to be between the AI companies, the utilities and research institutes like EPRI and large power generation companies, right? And it's going to be a joint effort, and AI is going to be a part of this. It's only an enabler. There's a lot of things that go into resilience of a grid. So it includes, design of the assets fundamentally over the lifetime, how they're operated, managed, and then AI would play its own role in this in contributing to the resilience. So so what I want to do is I'll just start off with an example, a motivating example of the famous 2021 Texas power crisis. As we know, I mean, if you look at the national grid, you have a well-integrated western side of the grid and eastern side, and then the Texas grid kind of stands separate as a standalone grid, which is most of which is managed by the ERCOT. And really, what the interplay or the interdependence between the regional oil and gas grid system and the regional power grid system, right? It is a very important one because the oil and gas assets, the core assets like compressors, pumps, and so on, they are highly dependent on the power that is coming from the power grid, right? And as well as heating of the pipelines, that is important to keep the flow going. And likewise, natural gas is a key source of power generation in Texas, right? So it obviously depends on the oil and gas grid system. So now, if you throw in climate influence, right? So we have a lot of changes happening, as Dr. Min spoke about initially. For example, today we're talking about the risks of wildfires due to electric grid faults and proactive outages due to prevent the damage, right? So due to some faults in the transmission lines. And there are a lot of shifts happening. So what happened in Texas is basically winter influence failure mode. So we were seeing actually freezing of gas pipelines, freezing in instrumentation. A lot of the initial attribution of this crisis was given to wind energy, but it turns out that it was still a small fraction of the total mix, right? So icing on the wind turbine blades did play a small role, but really the major role was the load shedding on the gas stations, right, which happened due to a very high demand in winter, right, for power. And so the power, actually, the load shedding was also impacting the gas stations, but then the gas was feeding in the natural gas generators, right? And so that was actually causing a cascaded outage in the grid. And it almost reached a complete blackout situation before the action was taken. So the point I want to drive here is that understanding the failure modes at an asset level, right, and how the climate is influencing that. This is very important because a lot of the failures and issues start at an asset level, but then it is obviously very important to see how that plays out and propagates into the system level, right? And it includes also the response of in terms of load shedding and dispatch optimization and other things. And traditionally, a lot of the operation of the grids has been quite reactive. So we have, of course, we have the day-ahead markets where the bidding happens, and then you have the different levels of frequency regulation, tertiary, secondary, and primary. But now with AI in the mix, there is a lot of proactive planning that is happening in terms of asset performance management and predictive maintenance of these critical assets, right? So as part of Symphony Industrial AI, our focus is a lot on asset performance management and monitoring assets using vibrations and process data. And so we come from a bottoms-up approach. But the point I'll try to make here is that the failure modes at an asset eventually propagate and get to the level of the power grid, right, and cascading failures. So it is important to look at a very detailed level of failure mode analysis. And this could potentially change with time, as with climate change, you have new failure modes coming in. And typically an asset is designed for about like 20 years, right? Typically, and these failure modes can actually change over time as the demand profiles change, climate changes happen. So an example of that would be, you see, for example, natural gas generators have shifted from primarily base load to a lot of peaking and variable load operations, right? So that also has an impact on the failure modes of those assets. So this is an important thing I wanted to stress on. And in terms of AI, so how does AI come into bringing in this resilience and bringing that improvement? So firstly, just analyzing the data in terms of descriptive analytics. So looking at different data sources. So I think we saw in the previous talk, image data on the electrical transmission distribution side. But also there is a lot of time series data, a lot of maintenance logs and metadata. And basically aggregating these heterogeneous sources which are coming. And this is obviously a big challenge because there's different systems that are being used to store the data, different protocols. So how do we bring that all into a data platform and be able to visualize it, do different types of analysis like clustering, feature engineering, and kind of bring that context and understand, past failure modes and various observations from the data, right? So this is one important application. But of course, we're moving more on the predictive side. So looking at machine learning, operational foresight, right? Both supervised and unsupervised. So there's a lot of activity in AI companies and also the bigger companies on forecasting tools, right? So forecasting demand, forecasting weather conditions, forecasting time to failure. And the shift has really been a lot in terms of moving from traditional statistical tools like ARMA methods to more of deep learning tools like LSTMs, recurrent networks, transformers, CNN, and not just being able to forecast, but also bringing explainability into the forecast, right? So why is it that a certain forecast is a certain way? So to build more trust in forecasts, it is good to have the factors that are influencing the forecast and what are the confidence bounds and things like that. And also being able to forecast different regimes and provide more explainability on that. So that is one direction that we're kind of actively looking at and baking into the platform. And system modeling is always important, looking at both asset level models and network models, using a combination of data and physics. And finally, anomaly detection is one a technique that we use a lot in predictive maintenance for early detection of faults, right? So, and finally, last but not the least, in terms of prescribing actions. So once we have the predictions, what do we do with that and how do we reason out, right? So the machine reasoning part. And this is where our approach, what we are kind of proposing is that baking in FMEA templates, right, which failure mode analysis, effect analysis templates, which usually every plant would maintain, right, from a reliability standpoint, and the operators and reliability engineers are familiar with this. But how do we take that into more of an operational sense and combine that with AI models for diagnosing faults more accurately and proactively predicting certain failures, right? So this is something that we're actively looking at. And then there is also decision support rules and optimization engines. So the standard unit commitment and the optimal dispatch problems. So yeah, and this is just showing a library of templates. So we could, you have different types of assets: pumps, fans, compressors, engines, and then also the electrical assets like transformers, feeders, heat exchangers, and so on, which are part of these plants and which we need to monitor. Okay, so we believe that democratization of AI through domain-informed templates, which kind of bake in a lot of information that reliability experts and operators and power plant experts have in the form of templates, and also curated data sets like we saw in the previous talk. I think this is, and these would be anonymized and normalized kind of data sets, but this is very valuable. And in terms of machine learning, a lot of focus is on transfer learning. So how do we use pre-trained models, on a larger data sets? How can we effectively use them for new scenarios and just augment them with, new data? So this has been done effectively in the image analysis or in the NLP community, but in the time series world, there is still some work to do to be able to effectively use this. So we believe that these are definitely valuable things to look at, and where AI could play a role. And just to give an example, and I'll just maybe close with this.
Just a quick reminder of the time.
Sure, yeah. So I will just take a minute. So this is an example of a power utility where we looked at a boiler feed pump anomaly detection using a combination of machine learning methods, which shows that vibrations were kind of dominant. And then we bring in an FMEA template-based analysis, which has all the failure modes of the pump, along with the severity, occurrence, and detectability, and the risk probability number, priority number. And then you have a severity score, which points to shaft misalignment issue in the pump, with a recommendation to check and inspect for damage. Now we could look at a network model and system level FMEA to kind of roll up the risks. So in this case, multiple units and plants at risk due to an identified design issue with many different units, similar units, right, pumps. And then finally, this would could roll up to a utility level risk, where there are multiple plants which are at risk. So at the utility side, there is a high risk, and this could roll up to an RTO and national grid level with only the required information passed on. All right, so finally, I'll just close with a snapshot of what a data platform could look like. And this is a portal with live data coming in for all these assets. And you see that you have these pumps and turbines as part of a plant, right? And the risks actually are factored in the form of a health score. So you could have different levels of severity, and you have the risks actually rolling up from an asset level to unit level, and all the way to the plant level, right? And you could actually look at the health scores and what are the factors impacting it. So in this case, this is the unit that is kind of impacting and is a higher risk, right? And you could also have a way of tracking alerts, changing the status of alerts, and analyzing these alerts in more detail using a data-driven platform. So I think with that, I will close my talk. And I just want to just to summarize, we believe that failure mode effect analysis and risk analysis at an asset level is very important, and then to understand how that flows to the overall system level risk to build in resiliency in the power grid. So thank you.
Perfect. Thank you, Prashant. And let's move on. If we have time, we'll come back and or allow attendees to ask questions. So our next speaker is Sept Staples from Idaho National Laboratory. Sept, are you here?
Yeah, I'm here.
Perfect. I'll hand this over to you. Prashant, can you stop sharing?
Yes, sorry.
Yeah, I can. Just a second. Let me see if I can share real quick.
Yeah, I think I stopped.
Okay, can you guys see that?
Yes.
Okay. All right, so my name's Sept Staples. I'm the department manager for the AI Data Analytics and Visualization department under the Advanced Scientific Computing Group at Idaho National Laboratory. And I'm really here to talk to you about our AI machine learning strategy. We've got research going on throughout the lab. We've got 5 different mission areas, and then we also have the business side that, and everybody's doing AI machine learning now. And so one of the things that we decided to do kind of as a laboratory as a whole was tackle what is our strategy moving forward. And really, we really kind of wanted to share this kind of as a lessons learned, or some of the things that we're doing, maybe give you guys some ideas, or maybe some things that we can collaborate on as well. So with that, I'm going to kind of walk you through a few of the things that are inside of our strategy document, and we'll kind of go from there. So the strategy document really starts with a vision, and our vision really is to leverage artificial intelligence and machine learning to realize new insights and capabilities regarding the research and core competencies of Idaho National Laboratory. Now, this requires that our researchers understand kind of how this technology should be used, as well as how it should not be misused, right? As well as the appropriate usage of this technology. So there are 5 goal areas that we put goals on, and these are the methods, the data, the tools, the people, and the security. And each method or each goal area has a goal, and in each side of in the goal there are also objectives, as well as short-term actions that we can do kind of on a yearly basis. And I'm going to go over a few of them, not all of them, but enough to kind of give you an idea of what we're talking about. So the first one really is the INL will challenge existing research gaps by AI and machine learning. And this is the methods goal, right? So the first objective here is really advancing AI-based research and innovation across the 5 mission areas by adopting and institutionalizing AI into the research process, right? The second objective is to leverage our internal research and development funds to help us grow the capability here at the lab, and really help. And that means data, tools, people, those types of things. And we'll talk about some of the goals inside of those goal areas as well. Objective number 3 is lead innovation by emphasizing AI and machine learning capabilities and proposals, future opportunities, and we're going to do this through our community of practices. So some of the short-term actions that we have for goal 1 are utilize subject matter experts to identify the research gaps, and then work with external customers to facilitate increased secure applications and new and ongoing programs. So that's goal number 1. Goal number 2 is through its unique data sources and expertise, INL will leverage AI for insights into research gaps. So data is very, very important here, right? So objective number 1 really is leveraging our existing data sources. We have a lot of really cool data here, and how do we use that data to extract additional information and additional insights. Objective number 2 really is developing plans to process long-term storage. So getting that data off of laptops, thumb drives, external hard drives, closet supercomputers, and getting them inside of some kind of central repository where we can search it and share the data. Objective number 3 really is is helping us enhance kind of our sparse data. Where we have data that we don't have all of the data, can we use Mod and Sim to enhance it? Objective number 4 is new and existing data sets will be leveraged for partnerships for additional funding opportunities. So take all of this data that we have, especially with the central repository, and then start going after new funding opportunities. So some of the short-term actions for this goal is promote the latest AI machine learning capabilities by leveraging them on old or legacy data sets. And then explore the ability to fuse various data sets into standard format for use in further exploration. And that has to do with, that central repository. And that's it for goal number 2. Goal number 3 is really the tools. So we want to accelerate the transition of AI into INL applications like Moose and Relap and some of those types of things. Objective number 2 is collaborate with the HPC group to make sure that we have plenty of storage and plenty of AI machine learning hardware to enable us to have success with AI machine learning. And then objective number 3 is build a process and infrastructure around AI machine learning, so we don't have to reinvent the wheel, or people that are coming on that want to do these types of workloads don't have to reinvent the wheel. So the short-term actions would really be create that framework and the workflow for using different AI machine learning models, and then ensure the next generation supercomputer that we have meets the AI machine learning requirements. So goal number 4 is INL will develop and mature researchers' AI machine learning capabilities, and this is really about the people. So the first one is really developing those talent pipelines for AI machine learning through interns, postdocs, and graduate students. Objective number 2 is build a community of practice around AI machine learning and ensure that it synergizes with other community of practices, right? And then objective number 3 is provide training and other learning opportunities to advanced AI machine learning across INL. And this really is, how do we get people that are already here that want to learn about AI and machine learning, how do we get them up to speed, right? Objective number 4 is identify intellectual property opportunities, patents, copyrights, open source licensing, and apply for those licenses. And we've done a pretty good job over the last 6 to 8 months, going after those types of things. So short-term actions: sponsor competitions for talent pipelines, sponsor regular symposiums and workshops, which we do one every quarter at least. And then we have other spin-offs that we do. Develop LDRD calls, so that's the internal research and development calls that specifically focus on AI machine learning. And then strengthen our intern pipelines with strategic universities, year-round internships, and encourage more frequent course refresh, especially as fast as AI machine learning is changing. So the last goal really is the security, and this is where we talk about we want to have it trustworthy, right? So INL will ensure trustworthy AI machine learning that is explainable to end users and decision makers. That's the goal. The objectives: INL becomes a national leading force in trustworthy AI. Objective number 2 is INL creates guidance on the explainable scenarios for users and the alignment of machine learning methods to problem data sets. Objective number 3 is researchers build trustworthy AI into new research efforts funded by both the laboratory and our customers. And objective number 4 kind of leads back to the data goal as well, but it's really growing that security data set or that set of security data sets so we can share them. Short-term actions: research areas pertaining to adversarial machine learning, and what are the countering mechanisms and techniques. And along with that, the other short-term action is what are the countering, or what is malicious use of AI? What are people doing, and what are some of the countering mechanisms and techniques? And with that, I will end my presentation and take any questions.
Terrific. Thank you, Sean. Let's move on. Then if we have time, we'll go back and have an audience to ask a question. So our next speaker is Slavek Shrimba from Spark Cognition. Slavek, are you here?
Can you hear me?
Yes.
I should be sharing my slides now.
Perfect.
Okay. So yes, hello, thank you for inviting me. My name is Slavek Zaremba. I'm a CTO for predictive maintenance at Spark Cognition. Just a few words quickly about the company, because most of you probably have not heard about us. We're a small startup from Austin, Texas. The company was formed in 2013. We have about 300 people, and we focus on industrial applications of AI, predictive analytics mostly. From the very beginning, some of the key applications were actually in the area of resilience of assets, physical assets, and also cyber assets in the electrical power industry, power generation mostly. So what I wanted to talk about today and share a little bit of the insights that we have gained over the last few years as a startup trying to deploy technology solutions to a very mature field of industry. And a lot of people have talked about this already today. Tom Siebel talked about it earlier, right? About these two sides of the coin of AI implementation. One had to do with extracting these insights, but the other one also about preserving the experience from the SMEs, right? And it's not as mystery anymore. There's a lot of information about showing how these kind of implementations have failed over the last few years. In general, digital transformation type of initiatives, but also high-tech initiatives. And again, this was already well discussed today and yesterday a little bit as well. You know, this is about at the end, right? So how do we make this about people? And that we already have tools that come from IT, right? So we have the change management tools. We also need to make sure that, you know, everything that's built is relevant, clear, and manageable, and so on and so forth. But the question is really, how do we capture these insights? How do we capture the knowledge? How do we do the knowledge engineering? And include this in AI. So it's not just artificial intelligence, but it's AI assisted type of a solution. So because we are from Texas, obviously we had to look into the issue of the winter freeze. So similar type of experience and observations as Prashant just shared, but maybe with a little bit different spin here, and that is how to include the human in the loop, right? So you've heard about what happened there, and I was fortunate or unfortunate to be one of the people who have lived through the previous scenario 10 years ago. I worked for a big power company at the time, and we had several plants in Texas that went through the previous freeze, and there were a lot of lessons learned. A lot of them had to do with smart people, SME experience, that apparently was not captured enough, or the actions were not taken enough, and consequently we had what happened. So the solution that we're working on right now has three elements, and I'll just go very briefly through it because we have very little time. One of them is vulnerability assessment, which is similar to conceptually to what Prashant was describing. It's more generally based around the concept of reliability-centered maintenance, or if you're an EPRI member, or you're more familiar with the term equipment reliability. But it's a methodology that that's been around for 50 years, and it's very well versed to identifying high risk scenarios, identifying containment plans and corrective actions. And this is important to properly focus deployment of technology or deployment of process or the efforts, or where you would put AI or some other analytic or high-tech tool where it would be actually useful and valuable. And there's two kind of areas, and this is what these two type of solutions are: intelligent advisor and digital twin. One area is if you look at the outcome of these failures that took place in Texas this year and 10 years ago, and in the previous events, they had to do effectively with a lot of operational things, but also it had to do with instrumentation issues, right? And again, Prashant mentioned some of that a few minutes ago as well. So intelligent advisor, this is the concept that some people worked on 30 years ago and with expert systems. How do you provide an artificial assistant that would tell people who maybe are new to the plant about certain operational things they could do to improve resilience of the plant? So maybe they need to run some tests before the freeze comes in. Maybe they need to cycle some pumps. Maybe they need to make sure that the water is flowing as opposed to not flowing and then be subject to freeze. So providing an advisor or type of an expert system that would provide this kind of operational advice when it is needed. And the other one, and we call it generally digital twin, because this is what people usually are referring to these days. Again, a fairly old concept of inference of sensor values. And again, this has been around for quite a while. If you look at the history again of failures, especially big plants in Texas this time around, for example, the nuclear plant close to Houston, it failed because of incorrect reading, a failure of freezing of a sensing line for one of the pumps. So these techniques are there, and they could be utilizing various type of methodologies and approaches. Could be physics-based, could be an APR type of a solution, could be a neural network, could be completely and machine learning type of a solution. But the overall solution, what we're trying to work on and provide, is a hybrid, right? So
Hey,
we're
Mark
utilizing as
McGranigan
much
is in the Resiliency one.
I'm sorry.
Slaver, I think you can go on. You can go on, please.
Okay.
No worries.
All right. So yeah. This is just, I'll just wrap up. So effectively, the idea is to implement something not outside of the human, but around human, and with the utilization of SME experience to build something for the person. And just last note, you've seen the silhouette of a man and a dog. This is probably the oldest joke in the book in power generation industry. So the idea is obviously is that to achieve the of the man and the dog running the power plant, but in a way that they would both accept it by the humans and also utilize as much of the capability of the humans that we can. So thank you very much.
Terrific. Thank you, Slavik. So we have about 7 or 8 minutes, and let's keep moving. So I will open the floor and say, for all the participants, if you want to ask any question to the previous 4 speakers, or if you'd like to share some exciting work that your organization is doing, this is the time. Please just unmute yourself and say, identify your organization, your affiliation, and share with us the exciting story. Anybody would like to go ahead? Let me see. Let me check the parking lots here. So we do have a very, several interesting inputs on the parking lot. Let me see. We have a Sri Roger Goplan from Morano Corporation. And would you like to share with us some of your ongoing work?
Sure, absolutely, Dr. Min. So, believe it or not, there's a lot of things that are common between the United States Navy and electric utilities. Number one, both of them have nuclear reactors, right? And then nuclear aircraft carriers and submarines are cities and in their own right. So they have massive amount of power generation, they have massive amount of predictive maintenance issues and all that. And you guys have aging equipment, they have aging equipment, and with technicians with potential loss of institutional knowledge of nuclear and other mature technologies. And they want to reduce unplanned maintenance. That's one of the big things that they have. And there are 3 big areas that they focused on. One is the aircraft carriers, submarines, and then the shipyards. All 3 entities have massive amount of power generation, maintenance opportunities, improvement, and these are ideal candidates for digital twins. And that's what we're helping the Navy with through an SBIR, where SBIR is a Small Business Innovation Research project, and we're working with them to introduce digital twin to these areas for power generation, for predictive maintenance, and collecting accurate data. So they have a muddy data issue. So there's a lot of data that's missing in their entity. They have some data that has questionable accuracy. So we're helping them collect clean data, and then with that, use data science to predict future maintenance requirements so we can reduce unscheduled maintenance. So that's where digital twin comes in. And just to recap, digital twin is for both condition and current health monitoring of these assets, as well as for predictive maintenance. Dr. Min, over.
Thank you. Terrific. Any other question to the audience, to the speakers, or any inputs you'd like to share with us some exciting stories? Okay, if not, let's move on to the second part for the agenda. Is really try to discuss some of the gaps and also the path forward in terms of the topic energy system resilience. So we have 3 topics, but we don't need to be limited by these 3 topics. If you would like to suggest any topic we should discuss today, same thing, go to the parking lot and input the topic, the gaps you think we should address. Then if we have time today, we're going to discuss these topics. Okay, let's move on. The first one, I'd like to invite Sarah of EPRI to share with us, EPRI's ongoing work on the energy system resilience evaluation.
Fantastic. Thank you, Dr. Min, and other folks who are presenting here today. Can everybody see my screen?
Looks good.
Perfect. Thank you so much for having me here today. Just wanted to note that I'm here on behalf of a team of folks who have worked with me directly on the Value of Resilience Interest Group, and now continuing to keep tabs on industry research as well as looking for opportunities within EPRI, and then work with a ton of folks across EPRI from our position in technology innovation and through the interest group with key stakeholders, other research organizations globally. And just wanted to share very quickly a personal story related to resilience and little context for resilience. And when my partner and I had our first child, we experienced resilience firsthand. We were later in life, both had careers, and going into having a new baby, folks will know that you have a baby shower. And a baby shower is like your reliability event or your planning event for reliability, where you get the stuff that you are pretty sure you need, the stuff that everybody needs, the stuff your best friends have that people locally tend to get, kind of your all-threat stuff that you need to have on hand with the baby. And then there's other stuff you can get. You can get fancy coaching and training on all kinds of topics that are difficult when you have a new baby. Spend a little bit more money. You do a vulnerability assessment, understand where you have shortcomings or opportunities where you know you're going to need help and want to invest, for instance, daycare. And then when you start having challenges, you actually dig into what do I need locally, or given my situation, my unique little baby, who you may hear in the background right now, what are the things that are worth investing in that will pay off down the line? And we found that spending $300 on a sleep training class when you're 5 months in and about to feel like you're about to reach your limit, and we made that decision to invest that money, make sure that we had what we needed, process and something to help us get through something that was really difficult. But upfront, if you don't know you're going to have that challenge, maybe not worth investing. So a personal story about a journey of getting into resilience planning, and as you do so, you start to think about, what am I planning for, why, where, for whom are we thinking? We start thinking about solutions design. What is it that could support me in the things that I need, or support me in light of specific threats? We look at metrics, things like, for me, minutes between naps, or any number of things, decibels. I know very well how loud is too loud and what's the maximum white noise that you can have on for kids while they sleep. You value that. You figure out, how much is it worth to me to get this if I don't have it? What's my best option to get biggest bang for the buck? And then you work with your partners in making decisions to figure out what works best. As we try to figure out what to use for all of these pieces, as we make these decisions and getting into gaps, wanted to note up front that there are research questions and gaps related to all of these pieces here that you see. What are the right things to help us perform each of these actions, because it's different for every situation, different threats, different stakeholders, different communities. And then for folks who are actually having to make these decisions on resilience investments, there are specific questions that you want to be able to address through these different tools and metrics. For instance, when I think about the specific extreme event in my specific situation or the place that I'm planning for, what's the total cost? Although there are common needs, what you actually use to address that may be very different. And I apologize, you may not, hey, there we go. Now you'll see the header. The specific gaps that we focused on in value of resilience was taking threats and risks and translating those to societal value. And specifically, getting beyond what we might consider cost to really those things that have health and safety impacts. And in that interest group, working with folks across the industry and with existing research, the gaps that you see here are likely not surprising, and they are similar in other cross-cutting areas, but having sufficient data to predict costs or the value of avoiding costs in outages that last over 24 hours when the minute that's interrupted or the kilowatt hour that's interrupted really matters. Some matter more than others. Difficulty modeling customer behavior. We are in and of ourselves complex systems, and then we look at how we need to understand how those interact with other systems. And then something that we've heard about today already, incorporating uncertain climate futures. We have webcasts on this every day, and understanding how changes in climate, changes in extreme weather, climate risks may change that value is important as well. And the specific environment that we've used at EPRI, I won't get too far into it, but the links are shared. We worked with Run With It Synthetics through our Incubate Energy Labs 2020 challenge and had a pilot. You can see a project summary and a similar related defense application demo. But really diving into some of the spaces like in a specific community, what are the stresses that you have on community infrastructure and services or resulting health and safety risks that come from that during events? And specifically within their environment, their integrated modeling environment, they've got an AI engine. And I won't get too into specifics of the technology today and can pass those along later, or we'll have some of the SMEs on the webcast chime in. But they did include this AI engine. So as we worked with them and Salt River Project to add in some specific threat modules to model a flood, and then also a COVID-19 stay-at-home orders during utility response, work to develop some psychographic human modeling, and then the AI engine, as it's modeling these human decisions, economics, businesses, communities, bottoms up, is using any available data sets that are easily available and able to be used, and then essentially fill the gaps and create synthetic data where there are holes. And then just want to note that it's a really unique opportunity using this synthetic environment to do that gap filling. And aside from the ability to look at large data sets and leverage AI-based tools to see what the human brain can't see and explore what vulnerabilities look like and what might be worth investing in, really compelling to be able to use an AI engine and not just look at empirical data and what we expect to happen or have experienced historically, but also be able to model and see if we can find emergent scenarios or unlikely futures. So we've spent a lot of time talking with different types of stakeholders to understand what's needed in modeling and tools. And there is nothing out there essentially except for gaps. There are some fantastic tools right now that do help folks understand the costs of events and for different types of folks or different levels within society. And really excited to continue work with Run With It Synthetics and EPRI's modeling teams to better integrate that physical modeling with behavior and try to assess what some of this looks like to assist in investment decision making. Looking forward to the discussion today, and I would say that we welcome any feedback, input, and look forward to talking with you. Thank you.
Terrific, Sarah. I would say make a stop here and see any questions from the audience. So Sarah, let me ask you one quick question. So from utility perspective, in order to evaluate or value the resilience, you mentioned, the need for the data, right? And what kind of data that utility handle well or be able to contribute to the valuation? What kind of data that you think they don't have and they'd like to receive the help from other organizations or other sectors?
It's going to depend on the type of utility and the type of investments that they typically make and how they value those. So some of what Dexter and other folks have covered so far, talking about what's needed for infrastructure and understanding vulnerabilities in infrastructure, carries over here. And I think also the bigger pieces, the customer pieces, so understanding how customers think and feel, and then maybe more importantly, how customer preferences manifest themselves in terms of the products that they purchase, and then how they use those. And in resilience, like other areas, understanding the stuff that customers invest in that may have place a different value on the energy that they consume. That kind of changes the picture, and then understanding what they invest in for self-reliance that may be shared. So it may be as simple as understanding those interruptions and the amount of energy, the duration, and then it may get into understanding customer preferences and experiences and how they change, and then how that flows into the stuff that then impacts the energy system around them. And there hasn't been a whole lot collected even for things like load shapes, say for studying, for system planning is input to system planning. So understanding not just how new equipment operates, how people use it, what they're adopting, how they change how they use it as they experience events or have different programs available from utilities, is all fair game. And some utilities who serve customers directly may have it. And then there certainly is going to be a role for those folks like commercial technology providers, platforms, third parties that are working with customers, which is why it's a really sticky wicket trying to understand what's the value in sharing all of that. The governance, which I know we'll touch upon, really important.
Another quick question before we move to Jay is regarding the valuation resilience and also energy equity. You kind of touch a little bit at your talk regarding the resilience to different customer means different, right? And I think one example we see today for Texas, some of the data I received is the low-income community in some region of Texas hit the most for the winter events, right? And how, from the energy equity perspective, how we can use the data to really help the customers that they need the most help.
Yeah, and I think you said it right there. It really is understanding if you're able to segment customers, understanding how their behavior is naturally and then under duress or after events, and being able to segment that and understand how that how people's value of interrupted services and their ability to access resilient solutions, both in their homes and then possibly out in public settings where they may be using public transit or relying on electricity outside of their home, and maybe they're relying on it more heavily there than within their home. Really important. And I think in particular, because if you're talking about metrics and decision making, you may be talking about designing programs and understanding where will the investments be made, where will the most reliable, most resilient, beneficial behavior be happening, and then where are there opportunities to fill gaps and what would actually support customers and communities in that. Yeah, really important. And we'll be hearing a lot of that, and then continuing to understand how that sustainability, equity, sustainability, and resilience overlap.
Terrific. Let's move on. Any other questions from the audience? Okay. If not, let's move on. I will hand this to Jay Singh from CPS Energy. Jay, we're very glad to have you back, and you presented and participated in the roundtable almost 6 months ago. And some of the points you touched are very exciting. And I'd like to get your perspective, especially from a utility executive, and how we can move a lot of. We heard a lot of exciting pilots among the utilities, right? How we can move from pilots to really enterprise adoption of advanced AI technology. It could be more than just a resilience topic.
Yes, absolutely. So can you guys hear me okay?
Yes, we can hear you good. Yeah.
Fantastic. So first of all, thank you so much for inviting me into fantastic content, by the way. Slavic content you guys just shared. I'm just super impressed, and which is taking talking, which is fantastic. Sarah, I loved your starting point on when you have a baby and you have to resiliency. I was wondering when you're going to get to the point of potty training, because that's totally worth the cost. Whatever it costs, pay it, because that's quite a hurdle as well. If you haven't already passed that point, then I think you will at some point, and the cost will be worth it. Just ask for everyone's apology up front, because I am using my LTE. We had some thunderstorm last night, and the broadband is gone for the time being. So on myself.
Jay,
so I'm just
you kind of break out in the middle.
Oh, can you hear me okay, or still having problems?
I'm not sure it's just me or everybody has the same issue. You kind of break out for like 30 seconds in the middle. So one suggestion is
Leon. I missed out on what you were saying, Jay.
You may turn off your video. Just leave the audio there. May help the bandwidth.
How about now? Can you hear me okay?
Hope it's getting better. Yes.
Is better? I apologize, guys. Bandwidth is an issue at the moment. So I'll start with my introduction, and that will be helpful in terms of some of the points I'm going to share later. So my current role, I'm the Vice President of Digital and Data Transformation at CPS Energy. Before that, I did digital business development for McDonald's Corporation out of Chicago. I worked in their office in the Bay Area. And before that, I was doing the digital innovation for Target Corporation out of Minneapolis. And why this is important is in all of my previous roles, I had the opportunity to work with a lot of startups, venture-funded startups, accelerator-funded startups, and even startups in the later stage, Series D, Series E investments, and they were large organizations that were trying to launch pilots and go to production in some of these large organizations. So The challenges are not that meaningfully different for a company, whether you're a AI-based startup or a blockchain-based startup, or just a better business model using just basic HTML. There are challenges which are similar to all of those. So I will really break it down into 3 big buckets. The first big bucket is what I like to tell the entrepreneurs and the companies that I work with is you have to widen the scope. What I mean by that is, whenever there is a solution, especially a technology-based solution brought to table, things like what we're talking about today, AI. We want to use AI to solve a problem. And sometimes the focus is super narrow into the specific problem that we want to solve with a specific data set within specific department of the organization. And the pilot may be helpful. The definition of the problem and getting the right people to talk to you and getting the pilot going is very helpful. But to move from pilot to production, the first thing you must understand is the broader people, process, technology set. These 3 things must align for your solution to move into production. So I'll give you an example. Internally, our team built an AI solution for vegetation management. And we wanted to leverage all the LiDAR data, and we wanted to take it to our internal teams to say, hey, now we've used LiDAR data, we can do better prediction of where you need to go do vegetation management. So here are some recommendations, go use it. And we noticed again and again and again that the team wasn't using the solution we built. They still wanted to go back to the list of complaints they got the customers from vegetation management. They were going to prioritize those. That's what they're going to work on. And it really didn't matter what our model was telling them. And so what you have to do in that case is just take a step back and understand, how does that team, how does that group today make decisions? How do they prioritize their work? How is their work rewarded? And then you have to think about, okay, when I insert my solution into this big picture of the people, the process, the technology, the combination, when I change one element, how will it impact the people in the process? And unless your solution thinks through those other components, you will have a hard time getting adoption that really goes to production. So the way I think about it is I call it the entire experience. Think of the entire experience, the people, the process, and technology, not just the one element of the solution that you have developed. And the better you are at causing less disruption with the people and process, the higher likelihood you have of getting to production. So now, with something like AI, you by definition are causing disruption. So this is your opportunity as part of doing a pilot, is to understand the people and process element of where you're applying your solution. And the better you can be in bringing the people, process, and technology together, the higher likelihood you have of taking something to production. That's the number one lesson I can share across all the different pilots I've been able to bring to production. The second thing, I want you to put on your business hat. What I mean by that is you have to get some business development going as soon as your pilot starts. So what I've noticed in a lot of the times in some of my pilots which were less successful was my startup team or my head of product, whoever I'm working with on the solution side, is super focused with a small team, including the managers, the analysts, the people on the ground that they're working with on their solution. They're super focused in proving that their solution actually works. They're influencing a very small group of people on how their solution works. Once you get into an organization with a pilot, the number one thing I'd like you to do is go meet as many people as you can. Try to meet higher up in the organization. Try to meet the VPs. Try to understand from their perspective how they view the problem you're solving. Try to understand their language. What words do they use? Why is this important for them? And that broader business development, that sales, the salesiness of that process is super important. As your solution matures, as your solution shows any value, you have to be able to talk about your solution in the broader context of the organization. And to do that, you have to put on that biz dev hat. You have to go make relationships. You have to try to have lunch with as many people as you can. Go beyond the project team you're working with. I have seen startups and their CEOs and their founders were extremely good at that. Through those conversations, they were bringing insight into the initiative where they were pivoting the initiative based on the conversations they were having with the other VPs who were not part of the pilot at all. And that allowed them to be more successful. So once again, it's similar to the other idea of widening your scope. Think about people, process, technology, but also think about other stakeholders in the organization that you have to go connect with and learn from before you be taken from production. And the final thing I would say is and this is a hard one, and so I kind of reserve it and I don't talk about it a lot. This is really, I think everybody should be familiar, especially the startups. Utilities as an industry has a lot of specialized requirements, whether it is cybersecurity, whether it is data privacy, whether it is scalability, and your solution comes to the table. And you can't quite create a backup. You can't part of the organization to learn and to educate, but to go in production state where you have to now deal with your people. These are the things that are.
Jay, I think you break out frequently again.
Oh, I'm sorry, Professor Mann. This is my bad broadband. But then, that was my last point. But that's all the three things I have. Then one is the solution, that is people, processing, technology, and number three, infrastructure action. And by infrastructure, I mean scalability. So that was there. Hopefully that was helpful.
Thank you, Jay. Appreciate. Let me, I read a very nice comments, very insightful comments and topics. Thank you, Jay. And any question from the audience or any other utilities you'd like to share, some of your story and the insights, how you move or how you plan to move pilot to production? Jay, I hope the internet still work. And I have one quick question. You talk, give a lot of insights about utility, but we all understand that utilities operate in a highly regulated environment, and the CPS is slightly different. And but how we can get regulators and the policy buy-in, or your board to buy in the advanced technology like AI?
Yeah, that's a really loaded question, and I think a couple of things I would say. One is there are some broader challenges with AI around explainability, around data privacy, around data biases. These are the topics that the regulators and the boards pay deep interest to. However, when we are doing an AI pilot, the board doesn't get that involved in those pilots, right? And it becomes our job to explain to the board why this is the right technology we want to use. And I think we need to start focusing on the value that the technology drives and how it hits all the requirements of affordability, security, resiliency, reliability. I think we need to talk about technology in terms of what value it drives, not try to explain how technology works, because honestly, there are a lot of technologies. Even if you have to explain to a board member, how does internet work? They don't know how internet works. And if you try to explain that, then you're going to end up in a situation which is not very, very useful. So while there are some broader topic that everybody's paying attention to around the data bias and data privacy and explainability, but I think at a pilot level, I think we need to start focusing more on the value we try inside the constraint.
Terrific. Thank you, Jay. Any other questions? Okay. If not, thank you, Jay. Really appreciate. I hope this is a echo again the resilience of infrastructure. Any infrastructure, electrical grid, internet is very important. Let's move on to the next topic. I think this morning or early this afternoon, depend on the time zone you are. We have a very interesting high-profile session regarding the industry-wide data sharing and the governance. And I'd like to kind of revisit this topic and get some inputs from all of you. And also, I'm not sure if Dexter's still here. I think he is still here. So Dexter, I have one question for you. Is regarding you mentioned that the database APRI is able to sharing with others. Let me ask an opposite question. How can we contribute if we have a very exciting and non-utility exciting data would like to share with others? Can we leverage your platform?
Thank you, Professor Min. That's a great question. I'll say that it would be nice to have an industry platform where people can openly contribute. There's a lot to make that workflow happen. We don't have that built, but if you look at similar industry data sharing mediums like the USGS, United States Geospatial Service, they have a lot of geospatial data sets that are publicly available to use for all different types of research and commercial uses. So that it's not something new that we need to build, it's just something similar. But yeah, and it's got to, in my opinion, I think it's got to be facing two different audiences. There are utility data sets that can likely be shared to the public domain because they contain low risk. I mean, it's or they could be scrubbed. But then there's data sets that are regulated and are bound under strong license, export control even kind of terms. And those could certainly benefit from industry collaboration, but they have to be managed securely. So we don't have that tool built, but I would encourage anyone that's kind of thinking towards this industry collaboration, medium, web-based medium. If you have some thoughts as to what that may look like, I'm certainly all ears.
Terrific. This is exactly echo the point regarding the data governance is also very important. Because in utility, as you mentioned, we have operational data and like SCADA, EMS, and the DMS, and especially on the transmission level, most of data is critical infrastructure data. They are protected, and but also we have a lot of non-operational data like GIS and AMI and a lot of equipment health information we heard today. They are non-operational data, and how we can leverage that. And also, there's a lot of external data, which is not managed and owned by utilities. For instance, like the data you mentioned, and also the weather data, and the satellite image information, even the social science data, like the census information. And in the resilience topic, one very important perspective is what's the cost of the blackout, right? The economic and societal cost, as Sarah mentioned. And this data are owned by various different organizations. And how we create a data platform and also a governance to ensure that everybody can benefit, but also data is protected, privacy is conserved, is considered on this kind of umbrella. So I think what you just described and is very good step. So I think this is also a question for both Jeremy and Dexter regarding the APRI data sharing. So if both of you or one of you can elaborate a little bit more regarding the data sets you plan or you are covering, like it's on the generation side, or it's also consider a bunch of transmission, distribution, and even customer information, and what's the vision for the next step?
All right, so Leon, I'll take the first step on that. So what we're looking at doing is trying to, from a high level, provide the most important data sets across the entire electric power industry. So whether that's plant operational data, satellite data, transmission and distribution imagery, AMI data on the meter side, those are some of the data sets that we're looking to bring forward. So we're trying to set up, and as Dexter mentioned, we're still kind of in the process of finding the best way that we can share that in a way that meets our cybersecurity requirements, in a way that we ensure that we've appropriately anonymized utility data before sharing that out openly. And we do have some data sets that, frankly, we're just not going to be able to share because there's very sensitive information, things like control center alarm data that we just can't release to the public. So we are trying to create a platform, and Dexter's kind of our guinea pig on this, to making sure that we go through all the right hoops and get all the right approvals in place from the utility side, from the EPRI side, and from the essentially covering all aspects of legal data sharing issues. So what we're looking at, just to give you a little bit of a peek behind the curtain, is setting up something like a data.epri.com website where you can go, and that would link to the different data sets that you would have. And we're trying to simplify the process in terms of have something like a click-through license where you can agree to the usage and sharing of the data, and then go through and get access to the data in a streamlined fashion. Dexter, anything you wanted to add on that process that you're going through right now?
No, I think y'all both added to the comment very well. So thank you.
Terrific. I'd like to give the opportunity to the audience. See if you have any question regarding the data sharing and the governance that EPRI is working on right now, or either you'd love to receive some data or you'd like to contribute some data.
Dr. Min, this is Prashant here. Just one question. So I just wanted to know if there are some data standards or some standard nomenclature and consistency in terms of data you get from different utilities or sources, right? So.
This is Dexter. We don't. Well, I take it back. We do in some of our data collection efforts to some of our industry databases. We have forms they fill out, and those are standardized. For some of our data sets, like imagery, it's kind of new, and we don't. We're trying to identify some industry standard language related to identifying what these objects are, and then showing some visual examples to help non-subject matter experts understand more in depth about the task that we're trying to do. And it's a little difficult to kind of pull industry along in that space because it's a boiling the ocean kind of approach. How do you think about all the intricacies of an inspection, for example, and all those different variables you've got to account for when labeling. We're working with organizations, IEEE and CGRADE, but we're not so much the standard setting organization ourselves, but we're giving them certainly some ideas and resources that maybe they could take and help implement for our industry.
Sure, thank you. I mean, it's a hard topic, I guess, but data curation is kind of important and useful for the industry as a whole. So. Thank you.
Okay. Any other questions? We have one comment regarding the AMI data. And the AMI data is likely require security as more powerful AI tools emerge. Yes, Tom's presentation did highlight this one this morning. But the AMI data is also another challenging issue is the privacy. So Frank, would you like to elaborate a little bit more?
Yes, I could. I hope you can hear me.
Yes.
Yes, I've thought about this. I have to say that Tom's comments this morning were eye-opening to me, who's been an attendant in some of the data churches that are around. I'm not a data scientist at all. I'm electric distribution, but there's power in it, and I like it, and I really like what he said. But the other side of what he said was that as more powerful tools emerge, it just requires the companies and even the governments to create controls where there weren't controls. And I had been of the opinion that by and large distribution data sets should not be encumbered by critical infrastructure security, which prevents our mission of sharing data and improving things for our customers. I think we're getting to the point that we're going to have to do something there. But if I was a general in the Army, I would find it hard at times to let security prevent my mission of taking that hill, for example, Iwo Jima. Think about it. If you let security prevent your mission, then you fail. So we have a mission to do, and we have to be secure about it. But somehow we have to find that balance and do it responsibly.
Yeah, I cannot agree more. I agree totally. Yeah, and also I think it will be a very long way to go because this is an area that how federal and the state, because all the distribution and more than distribute any resources, the huge potential security concerns, all the inverter-based technology, right? And but this is an area that the state has responsibility in how the state are going to consider the cybersecurity for all the DERs. And also behind the meter will be a completely different story. It's customer privacy data. And but I completely agree with you. Security is important, but also makes things working properly and seamlessly is also very important. Any other comments? Okay. If not, I will open the floor. Have a last call. Anyone on this, either you'd like to share with us a minute or two, some of the exciting ongoing work at your organization, or you want to, comment on some of the key gaps you observed in this area. Either way is fine, but each of you will only have 1 or 2 minutes. You can just unmute yourself and identify yourself, then go ahead and talk. Anyone?
Hello, can you hear me, Dr. Ming?
Yes.
Hi, this is Huiying. I'm a data scientist from Pacific Northwest National Laboratory. When we talk about the AMI data, it reminds me the projects I'm doing right now. Not only we talk about the data privacy, the cybersecurity things about the sharing data. Another issue we are doing right now is try to improve the quality of the data. We know the data have a lot of gaps that will affect the following the guidance to the power system model. So how to improve the quality and quantity of the data is another issue about the AMI and all the smart meter related data. That's maybe another perspective about the AMI data sharing. And also, I have been working on a lot of projects related to the AI, machine learning applications for the Earth, environment, and energy system, um, especially related to the environmental and the energy coupling projects, like how the extreme events affect the power system. We have been working on a series of projects that we can evaluate the relationship between the power system outages and the weather extremes. We're using the Bonneville Power Administration Service area as a test bed. Try to analyze the spatial and temporal information that and the recorded extreme events, how we can learn from those extreme weather impacts. The involvement of the geographic climate information can construct the knowledge extraction platform for accurate outage probability predictions. And also, we have a proposal on our list that we try to identify and classify the extreme events using them like the deep generative adversarial network and stacked variational autoencoder joint framework that learns the underlying data distributions of extreme events and generate some features for unseen classes from an unbalanced training set, and by synthesizing a new realistic training set that could be benefit for the community as well. Another project what I'm doing right now I'd like to share is we kind of start to build the system resilience machine learning models using energy dispatch optimization results and linking the financial cost or benefits with physical design parameters, see the battery capacity, dispatch timing and duration, those physical parameters, and try to give a reduced order model that can benefit for the system resilience. That kind of the integration between the battery design and dispatch optimization of machine learning projects, I think it's pretty cool. We can connect each components together. Yeah, I'll stop here. And if you have any questions, you are welcome to contact with me to discuss more. And I will save some time for more audience.
Terrific. Thank you. I think we still have time to take one more input. If anyone would like to take this opportunity. Okay, if not, I would like to say that welcome to this breakout room. So what we try to really create, we have a, I hope Jeremy is still here. We have 4 to 5 other breakout rooms on different topics: cybersecurity, smart cities, and environmental challenges, etc. And we are going to coordinate and digest all the inputs we received over the last couple of days and try to identify the next step. But a step back, what we really try to do is create an open, collaborative platform for everyone, more than just utility. We realize that a lot of national labs, ad hoc, PNL, NREL, and 14 national labs are very actively working on this area. A lot of IT companies and a lot of startups are very active working on this area. So we try to create a platform to allow everybody to be able to share your ongoing work and exchange information with each other. And more importantly is really try to identify some ground challenges that as a community, we can work together to tackle that. One example is about the industry-wide data sharing and the governance model. I think, Mark McGraham also shared a very interesting example from National Grid. Okay. So in terms of the next meeting, and we're going to coordinate with other working group or breakout rooms, but we try to have a kind of group meeting. If you sign up with aprilai.com, we try to have this kind of group meeting or information exchange at least every quarter. Okay, Jeremy, anything you want to mention?
Just really quickly. So first off, thank you, Dr. Min, for leading this Grand Challenge session. We're very excited to have you on board with us. Obviously, a lot of interesting things we're talking about today, and I know you're doing a lot of interesting work in this area too. And we have lots of passionate people here. So what we're probably planning on doing is we'll pull the statistics from the people who attended this session, and we will invite you to that group. So if you're on here, don't feel like you need to specifically reach out outside of this. We'll invite you as much as we have email addresses for all of you, which I think we should. And then you'll be able to get involved in that. And we're looking at how can we set up kind of a more active community where instead of having to wait for, an in-person meeting or a virtual meeting like this, where we'll find ways to have a platform where we can share data and information, kind of like Mark did with this document from the National Grid ESO in the UK. And then we'll be able to engage more and more together. And hopefully starting sometime next year, we'll be able to start meeting in person, whether it's at conferences or other events. And we will have our 2022 AI and Electric Power Summit. We're planning that for Europe and having that being in person about this time next year. So mark that on your calendars. We don't have a location finalized yet, but we are narrowing that down next week. We have 3 very wonderful locations that are picked out, and we're looking at hosting that in combination with a number of organizations in Europe, including the World Energy Council, a large utility in Europe, at least one, and a few others. So stand by for more information on that, and we're very excited to move forward in this area and have all of you on board with us. Thanks, Dr. Min.
Thank you, everyone, for your participation. Thank you.
Great session, guys. Good job, Jeremy.
Thank you all.